Class, good evening, class. Can we start?
Yes, doctor. Good evening, sir.
Sir, you can
Good
start.
The first,
evening, good evening. Unless it is not stated, I will be regular taking classes, right? So no need to ask whether I will be taking class or not. I do remember that I have responsibility of taking class at on Saturday and Sunday. So if I'm not free, I will inform you one day before. Right, class?
Okay, thank you
Yes,
very much
doctor.
So
for that
that you can
clarification.
plan. So that you can plan, right? So, okay. So, we are talking about pre-processing, and just a quick revision for those who missed the lecture, right? So, if you understand, data pre-processing is very important part of the machine learning applications, right? So, because of we have incomplete data set, noisy, inconsistency, so data pre-processing is much required step in the data mining and machine learning. Okay. So types of data generally nominal, like see if you have like name of a particular person, this will come under nominal scale, categorical, then ordinal scales, interval and ratio scale. You might have see this categorical, if you can divide the data set into categories, right? So that will be categorical, like see why you are sending this Aliyu. I don't need this. If I need attendance, I will get from Zoom. Okay. So categorical, like different categories, like your grades. If you talk about your grades, they will be in category, right? A, B, C, D. Ordinal scales like ranking. If you want to just rank the grades like 1 to 10 numbers, tall, medium, short, even your grade can be in ordinal scale. Am I right, class? Hello.
Yes, sir.
Yes,
If
sir.
if I'm asking that your mark, your grades belong to categorical or ordinal, which is the best answer? If I'm asking in multiple choice question that one your grade belong to nominal, categorical, ordinal or interval scale,
It's ordinal.
answer?
It's ordinal, sir. Ordinal
Very good.
scales.
Yeah, your grade will be, you are comparing, right? So if you compare that, this is the comparison, is not like A, B, C, D. But what of blood group?
Blood
Blood
group
group
is
will not be in
categorical.
ordinal, we are
categorical.
not comparing, right?
Yes,
Yes,
category.
categorical.
Yes, like see, tall, medium, short is like there is like comparison. So if there is comparison and like order depend on the appearance, so definitely that will be in ordinal, right? So so all these things where you are comparing, of course they are category, they are in category, right? So that will be treated as ordinal scale. Yeah. Interval scale, you have seen that IQ score, like percentile score, they will be in interval scale. Okay. We started with data discretization. I think you were able to understand this equal width winning without any doubt. Everybody was able to understand with equal depth winning. Then we came to this data cleaning, missing values. We deliberated that how to handle the missing value, and then data cleaning was there. This binning was most important. By I think we are able to partition the data set into equal number of bins by averaging the bin means, and they taking median. And then what we did, class, we did like bin boundaries, and we noticed that bin boundaries was the best approximation of the noisy data, right? So we did up to this point. I did just like okay. Regression we'll talk about later on, not now. Regression is also one of the best technique for smoothing out the data, very best technique. So this has many categories like linear regression, has like multilinear, and so many categories of this linear regression is, right. So this is also important concept. We'll talk about it into later. Outlier is very important. Anything which is not inside the data range is to be treated as an outlier, right? So we'll talk about outlier, not now, but it will be different. So approaches, there are many approaches to handle the outlier. You will know them, not like one approach. They are having many approaches. Yeah. So this is the outlier by histogram method. This is the one which is outlier, right? Yeah. Yeah. Clustering is also going to be used in the outlier detection. You will understand how clustering is helping in detecting the outlier. So, but not now. So, class, in data pre-processing, one more thing is remaining. We are going to talk about this data transformation. So, this is also one of the important step in the transfer, like data pre-processing. So, ready class? Ready for this? You remember, I am not skipping outlier using clustering. Clustering is our separate chapter, and like this statistical method is also separate chapter, and this is regression is one important chapter of the data, this machine learning. So I'm not skipping them. Only I will like teach them once they need it, right? Not now. So let's talk about data transformation. Ready class? Ready with your biro?
Yes.
Okay.
Yes, sir.
Yes, sir.
So, okay, so you knew what is happening in data transformation. Let me just tell you why transformation is needed. And the transformation is actually having very crucial role in this machine learning. You see, if you are talking about text data set, you have so many keyword and like text, right? Suppose University of Abuja, so keyword is Abuja University, all this thing. But you know, problem with our computer is that computer is having problem in understanding the text. Computer is always trying to understand the numbers, right? So, and why number? Because number can easily be converted into binary format. So that is the problem with computer. So even in text processing, computer will not understand English text. So computer is always trying to convert, approximate that English into the number. Once you get the number, that number can be easily converted, right, into the binary format. That is why we need data transformation. That is the essence of the data transformation, right? Yeah. Objective is clear, class.
Yes, we are here.
Yes, sir.
Objective
Yes,
of this data transformation is clear. Why we need data transformation? You know, data transformation, sometimes most of the time it is needed in a pre-processing. Why? There is reason. Like, you know, if somebody is talking about do some analysis on news articles, right? So if you are doing analysis on news articles, and if you remember, your news is online news, and news is always English text, and problem is that processing English text is always a problem, and it is never complete. So because computer, problem with computer is always trying to convert everything, transform everything to the number, right? And once you get number, number can easily be converted into binary number, machine readable format. So this data transformation is needed to convert text, to transform text into the number, to transform big number into a smaller number, or a small number into the big number, right? Sometimes even if it is very small, which is hard to study, right, very tiny, so it is scaling to make it very big number, so that you know, you might have seen that zoom in, zoom out, right? It is just making it big so that you can see easily. So what is happening in data transformation? In data transformation, the data are transformed or consolidated into forms appropriate for mining. So data transformation can involve the following. First is smoothing. Second is smoothing. You have seen it already, right? Smoothing and bin smoothing, median smoothing. You have seen aggregation. Aggregation is just like summarizing the different data set into one, where summary or aggregation operations are applied. For example, the daily sales data may be aggregated so as to compute monthly and annual total amounts. So that aggregation is also important. And normalization is one of the important transformation where the attribute data is scaled so as to fall within a small specific range such as -1 to 1 or 0 to 1. Right, so this normalization, aggregation, smoothing, there are many steps of the data transformation. Can you give me one, can you tell me one answer of one question? Have you seen your camera, mobile camera or digital camera or any camera? Class, class, are you
Uh, Pardon, I couldn't get your question very well, sir.
camera, digital camera? If you talk about this camera from where you are taking picture, right? You know, if you are taking picture from any camera is always like its size always is square. I don't know whether you notice it or not. Class,
So
If
I
we
have no
notice what?
idea.
you don't have an idea?
E-
I didn't get it clearly. If you say if we notice what?
Let me explain. I'm talking about digital camera. Are you getting my point?
Yes.
Okay. Let me, don't worry. I will ask maybe in more simple way. This digital camera, you are taking picture of a human being, right? Or you are taking picture of a hill station, right? You are taking picture of hill station. You are taking picture of a human being, or you are taking a picture of ant. Let me ask, are you changing the camera for taking picture of the ant?
No.
No, no, sir.
Are you changing your camera if you are taking picture of a hill station?
No, no.
No, sir.
Oh,
And you are taking the picture with the same camera of a human being also.
Yes.
Yes, sir.
How it is happening, class? If your camera is having unit square, you know, mobile camera or any digital camera, its length is always unit. Reel is having unit length. Everybody has to fall within this. Everybody has to fall within this.
Yes.
Same thing, our eye. You know, we have our eye. Our eye can see the ant also. Our eye can see human being, but our eye can see big building. Our eye can see this hill station. You know, our eye is also having retina inside, and retina is always of unit square. Image is always coming in unit square length. It is not changing. So my question is that if this is unit square, everybody is falling within this. Am I right?
Yes,
Hello.
sir.
Yes.
Yes, sir.
Okay, let me ask one thing. This is your unit square frame. Unit square, length is 1. And you want to take its very, very big picture. Very big picture of a frame. Very big frame. You are taking its picture. Like, you know, this is a ant here, ant sitting here. And you are taking its picture here also. Tell me, is it going to be destroyed or it is going to be the same ant here? Big one is the same, right?
Yes, sir, it will be the same.
And even if you want to bring from big to small, it will be the same.
Yes, it will be the same
Yes,
answer.
it will be the same, sir.
So that is the transformation. You know that is the transformation. Is transforming in all the direction equally, right?
Yes.
Yes, yes.
It is not like you are changing camera if you are taking a small picture or big picture. Everybody is falling within this and everybody is transformed equally to this. It is transformed back to this. So this is reversible transformation. So this is what we are going to talk about in data transformation. Is it clear? That is what we are talking about, normalization. Everybody has to fall. You know, if you are writing examination, your marks are always normalized from 0 to 100. It doesn't matter how many marks you are getting, but your upper limit is 100, your lower limit is 0. So is it not a normalization class?
Yes.
You know, if you are setting a question paper, me like, see, if I'm setting question paper of 150 I'm setting, no problem. I can set a question paper of 150. Out of 150, you are getting 120. I hope you are following. Out of 150, you are getting 120 marks. So can you tell me how much marks you are getting out of 100? Class.
70. 70.
How you are calculating? You are getting like, yeah. Can you explain me, class? 80%, right? You know, 150 out of 150, if you are getting 80, 120, that means you are getting 80% marks. Are you getting my point, class? 120 out of 150, right? Hello,
Yes,
right?
sir.
Yes.
Yes, Prof.
80% marks you are getting that. So in 100, how much you are getting? Tell me. Are you not getting 80 marks?
Yes.
So is it not like if in 150 you will be getting 120? Is it not a reversible transformation?
Okay.
Yes, sir.
This is the transformation. This is not new to you. You know it already.
Yes, sir.
Transforming from one domain to another domain. So this is known as normalization. Okay, can you explain me if you are getting 120 out of 150, in 100 you will be getting 80. How much marks you are getting in one? 80% of one. How much? Is it not 0.8?
Yes.
That is it, sir. 0.8.
This is normalized between 0 to 1. So, but it is going to be the same. 0.8 in 100 will be 80%. 0.8 in 50 will be 40 marks, right? So this is equal transformation class. This is our today's topic, normalization, right? Aggregation, smoothing, so many data transformation techniques are there. So I wanted to tell you that don't be scared from the transformation. You know, okay, transformation is actually 1 minute class. Hello? Hello? Who is this, please? Good afternoon. Who is this, please? Jafar, I'm in a class. Can you call me after 2 hours? Or it's better that you can call me tomorrow. Yes, please, yeah? Okay. Class, so you know this normal transformation is part. Same thing is happening to us also. We are transformed from the childhood to, like, let's say, like teenage age, then upper age, then 50, 60. It is just like a transformation. Whole body is being transformed. Okay. So normalization is the one which is very, very important topic. And this has three methods. Minimax Z score, you might have seen it. This is also known as standard score, and normalization by decimal decoding, decimal scaling. So these three methods are there for data normalization. Class clear? Let me explain them. I will come to here one by one. Let us understand this is standard score. This is a mathematical terminology. Dr. Rose may be aware about standard score or Z score. Let me tell you why it is important. You see, it is already written that if you are getting 90 marks in ICT and 60 marks in math, which marks is better? It is out of 100 class. Which marks is better? Hello.
It's 90.
90 marks is better. Huh? I'm
Yes.
asking some other input also.
Yes, yes.
Which one is better, class?
Out of 100 marks, 90 marks is better.
What is in your mind? You know, if you are saying 90 marks is better in ICT, so what you are keeping in your mind? Class, what is
Yes.
in your mind?
Because in analyzing it, you see that 90 shows a good performance.
90 shows a good performance and 60 is not a good performance, right?
Yes.
The
Who is
max-
this? Who is this?
maximum
Who is this saying that 60 in math is not a good performance?
is a good performance. It's just
No, what I said is in analysis, 90 over 100 is a better score than 60.
But me, I will say no, it is not a better score. This is better. I can prove it.
Okay.
Where most of the students in mathematics are failing, and you are saying that 60 is not a better score. And tell me who is failing in ICT? Are you getting my point?
Yes, I understand now.
So this 60, you know this, I'm coming to the relative scores actually. This 60 may be the highest score in the class, right? Hello class.
Yes, yes.
60 marks in math may be the highest score in the math, but 90 may not be the highest, 90 may be the lowest.
That's right.
Because everybody is getting more than 90, so if a student is getting 90 is not a good one. Because in the class of 60 students, most of them they are just like getting more than 90. And only 2 or 3 are passing in math, and 60 is the highest. So now tell me which one is better.
If,
So,
if we do by scaling, the types of
No. Go by performance wise. Don't go by number. You know, number you may be thinking 100 is 90 is better than 60. Don't go on number. Don't go on figures. Go on performance wise, relative grading.
okay, then so in that case, if the 90 is the lowest in the class, that is a low performance.
Yeah, that's why I wanted to hear from you. That's a terrible performance. It's not a good performance. Am I right?
Yes, sir.
that's
You know
right.
what you are thinking in mathematics, like mind is difficulty level. Why I have put ICT and math together? I'm just thinking about my difficulty level. You know that in ICT, at least you can write something even if you don't know in detail, right? So
Yes.
if somebody is saying that explain keyboard or explain mouse, explain computer, what are the input output. So even if you are not understood properly, still you can prepare 4 boxes and so something. So there is no accuracy that you will be getting 100% marks. There is no definite answer. But in mathematics, if somebody is saying calculation which is having a definite answer, right? Suppose 2 plus 5 equal to 7. You cannot write 6, you cannot write 8 because it has a definite answer. So you will be getting 0 over there, right? So difficulty level in math is always higher than ICT. Everybody knows it because ICT has some theory, something English people can write. Mathematics has no theory. If you don't know, you cannot write. So if you think about this, a student is having 60 marks in mathematics, that means the student is the best student in the class. While grading this person by awarding A grade, this person can be scaled to get 100 mark. Ultimately this person will be allotted A grade. So this is the possibility. So let me just conclude it over here. This standard score is very much needed when you are talking about this kind of comparison, right class? So you cannot compare performance of a student in a class without calculating standard score of the class, right? And the standard score of the class is basically class mean and class deviation. You will see that standard score will be calculated in terms of mean and deviation within the class. Are you getting my point? Hello class.
Yes, sir. I think I'm
Don't
getting
worry,
it now.
don't worry. Once I'm coming here, I will explain it. This is also like normalization by decimal descaling. This is also very important that everybody has to come between 0 to 1. This is one of the tasks. So let's talk about minimax normalization. This is needed whether you are taking picture of a person in unit square or whether you are taking picture of a person in this, that person will remain the same. Person is not going to be changed. It doesn't matter what reference scale you are changing. Person will remain the same. Right class? Person is not going to change. Its dimension remain the same. This is the minimum maximum normalization. Okay. Yeah. So I want to explain one example and then we'll write a formula. Is it okay?
Okay, go
Class?
ahead. Go
Yes,
ahead.
sir.
Yes. Let me erase it because it is still written. So I used to save it. Note down this class. Yeah. Very important question. Yeah. You see here. You have source 100 and 100 to 500. This is the source. Lower is 100 and the highest range is 500. That means you are starting from 100 going up to 500. This is your source. Are you getting my point class? This is your source of a number and this destination, any number in this range is going to be converted between 0 and 1. This is the destination. This is the destination and this is the source. So I want to know how to convert a number. V dash. Suppose V is a number. V is 300. 300 is falling within this. Look at here. So your task is very simple class. Just hear me. Don't see the solution. Where you are going, find out its length, range. So where you are going, destination is 101. Calculate its range. 1 minus 0. I hope you understand. You are going here and calculate the range of the source, right? So range of the source is 500 minus 100. This is your scaling factor, right? After calculating this, let's calculate this. So this is 1 by 400, right? This is the number. I hope you understand this. And after this, right? You know, you are converting this thing, this multiplied by this guy is being converted. So 300 is the guy after calculating minus minimum of this value, minimum of this value, source. Minimum of this source is 100, right? After calculating this, after this calculation, whatever answer is coming, add minimum of this value, minimum of the destination, right? Yeah. So this is 200 divided by 400, right? Plus 0, making 0.5. Can you note down this? Class, note down this. I will give another example. This is 0, this, okay, don't worry, I will explain another by another example. Note down this. Noted.
Just a minute. A moment. Okay. Done.
Okay,
I'm
good.
done.
Let's send like 100 to 50. Let's send 125. 125 is still here. So in order to send this will remain the same. Scaling will remain the same. What you should do, class? 1 by 400 is not going to change. This is the scaling times, what is the number? 125. Yeah. Minus,
How did you bring 125?
this is the number which is written between 100 to 500. This is going to be transformed, right?
Okay.
And what is its lower value? 100. This calculation plus lower value of new destination is 0. Yeah. So this is 25 by 400 plus 0. Can you calculate this answer, class, value? Is it not 0.0625? Hello? Is it not correct? Class,
0.0625.
noted, right?
Yes, sir.
Yes.
Yeah, this 125 is being transferred. Remember, this is reversible transformation. Reversible means that, okay, I note down this, then I will explain in detail.
Can you show the previous slide again? I want to ask something.
Here,
Yes. So under this normalization, you have shown us minimum and maximum, which you try to explain. Then on the z-score normalization, is it the one you use 90 and 60 to give example?
I will explain it further. I just told you that what is its need.
Okay.
I'm not done till minimum maximum. I'm
Okay.
still working on it. So are you done with this?
Yes.
Okay. Let me
Yes, sir, but I
explain.
don't know how you go 125, sir.
125, any number within this range. You know, your source is 100 to 500. So if I'm asking to convert 125, take it to this value, this range. So if you are having any number within 100 to 500, 125, if you are converting this number in this 0 to 1, it will be equivalent number 0.0625. Am I right?
Yes, you are right.
Yes, sir.
So it means that the first one we got 0.5 is within the range 0 to 1.
Yes, definitely. You remember you
Yes.
took 300 in this range and you
Yes.
want to change this number to 0 to 1. You know it is a proportion. You cannot transfer two number to the same number in destination, right?
Yes.
So this number of 300 was converted into 0.5, right? Okay.
Yes, that's correct.
Let me ask one more. Can you convert 275? Just 275 to 0 to 1. 275 in this range, right? Hello, class.
Yes, sir.
Yes,
275, this lies between 100 to 500, right? Your question is to convert this between 0 to 1. Go ahead and do it. I'm giving you time. Let me see.
0.4375.
0.4375,
4375.
right?
That's what I got.
Let me see. 1 by 100 remain, 400 remain the same, right? We are not changing. And
Yes, sir.
275 minus minimum
Yes.
is 100 remain the same, right? Yeah, plus 0.
0.4753.
0.4753. You know this will be
0.4375.
5.
0.43.
375.
You know what is beauty of this? No other number will be transferred to this number. Am I right? No any other number of this domain will go to here. Is it clear or not? Hello.
But what happened to the maximum? That 500. Is there anything going to happen to it?
500 will be transferred to 1. You can check it.
Okay.
Check now.
Okay.
Check now. Check 500.
Yes, it's 1. 400 over 400 is 1.
It's 1, sir.
Yeah. And what of 100?
Is 0.
So everybody is going into that. This is the rule, yeah. This is something, that's why I told you at the beginning, it doesn't matter whether you are taking picture of a hill station or hill, or taking picture of ant, or taking a picture of very big man. It doesn't matter. Everybody has to come into that camera. Because it is a transformation, it is normalization. Camera is adjusting all this thing into a particular frame. Just like your eyes, we are not using our eye is not having camera, retina, class.
Yes,
Yes.
yes.
Yes, yes, sir. Yes, sir.
So it doesn't matter whether you are taking picture like seeing Baba Buhari or seeing this Bola Tinubu or seeing Lucy. Everybody will be in that picture. Am I right?
Yes, sir.
Yes, sir.
Do you think that your eye will see differently to Bola Tinubu and see differently to Lucy?
It's the same thing, sir.
Huh?
No, sir, it's the same, sir.
So same thing is happening here. Can't you see it? Everything is transformed. If you are seeing that, okay, 100 to 500, any number is being transformed to 0 to 1. Everybody will be transformed uniquely. Am I right?
Yes, sir. Yes, sir.
It's not like two number will be mapped together. No, it will never happen. This is the rule and regulation of the normalization. Normalization itself is saying that everybody has to fall into that category. It's not like rule is for something for different person. No, normalization meaning that if something is being decided, everybody has to fall into that category. That is the normalization, right? Okay, let me just explain you separate different thing. Yeah, I'm coming. Okay, class. So you have, okay, you have, I'm coming. I told you that this is reversible in nature. Now I'm following different approach. I'm following this to this. Again, listen me, class. I'm following this source and this destination. Is it possible or not? Class. Hello.
I think it's possible, sir.
Yeah, so can you convert 0.5? Let's see. You have source this and you have destination this. Now this is source, this is destination. What is scaling factor? I told you what was scaling factor. Destination maximum minus minimum divided by source maximum minus minimum. Can you, if you are taking this source, this destination, what is scaling? Tell me. Destination, how much is the destination, class? 500 minus 100. Am I right? Hello.
Yes.
Sir,
Yes.
500.
Yes.
Yes, sir.
What is source?
1 minus 0.
0.
What
Zero.
is its value? Is it not 400?
400 over 1. That is 400.
And you want to convert, let's say 0.5. So I'm converting 0.5. 0.5, right? Yeah. And what is its source lower? Source lower is 0. Remember?
Yes, sir.
Yeah. Plus destination lower. What is destination lower?
100.
Yeah. Can you calculate this for me?
Okay. 400.
Prof,
300, sir.
Doc, please, are we on the same screen? Because it seems I'm not following.
Why?
Okay. Okay, it's coming now.
Maybe your network is poor.
Yes, but it's up now. You are.
Are you in
Everything is
Kasina?
corrected.
Are you in Baba Buhari area? Or you are in Bola Tinubu area?
It's Buhari area.
Buhari area. So you will not get the network, I know.
Sir, it's 300, sir.
Yeah, it's 300. Good. Are you not getting the same answer, class?
We are getting the same answer.
Look at here. This 0.5 was converted. 300 was converted to 0.5. And now 0.5 is converted to 300. That means this is reversible in nature, right?
Yes, sir.
Okay.
Yes.
Let's try 0.0625. So you see your scaling factor, main thing is scaling factor, 400 into 0.0625, 0.0625, right? Minus what is lower? Lower is 0, source lower, you remember, source lower 0, plus destination lower is 100. Me, I want you to give me the answer.
$125, sir.
Wow. Are you not getting the correct answer?
We are getting it, sir.
Yes.
Look at here. You are getting 125. Remember, this 125 was the one which was converted into this, right?
Yes,
So
yes.
what you need to remember, the scaling. Let me repeat again. Where is source, where is destination? Destination difference divided by source difference. That is your scaling times any number within this. Write down the number minus lower of this, right? Lower of this plus After this calculation plus, write down plus, this is hundreds lower of the destination, right? Class, is it okay? Hello?
Yes, sir.
Okay.
So, but
Yes.
we want to write down the formula.
I'm coming. Let us finish it. Then you can, I will give you the formula, no problem.
Okay, sir. Okay, sir.
Okay. Suppose a number is written in 100 and 400. This is your lower. And range is 5 to 10. Question is that can you convert 300? Check the answer. It should get this. Check the answer. Source is 100 and to 400. Destination is 5 to 10. Your number 300 need to be transformed to 5 to 10. Do it now. Check the answer if you are getting the correct or not.
Eight 8.3333.
Correct, right?
Yes.
And you see, if you go and reverse also, you will get the same thing. Destination is this, source is this, and then 8.33, its lower is 5, and you can add the destination 100, you will get the answer. Are you done? Noted?
Yes, sir, it's the same. When you because of the point, we have 2999 approximately 300.
Yes, you know this because of the approximation, it is happening like that.
Yes, sir.
But you should not worry about that. That approximation is not going to affect you. Okay, can you note down the formula?
Okay, sir. So this the formula, the way you mentioned it, like destination over destination range over source range.
Formula will not be written like that. That is the difference between the textbook and teaching.
Yes.
So you can write somewhere if you are. That's why I didn't give you the formula at first attempt, right?
Yes, sir.
So you need to memorize by yourself.
Because if we follow this formula now as it is written, that means the number we are adding will come under as the divisor.
Formula is the same. There is no change in the formula. Formula is the same. Look at here. V minus minimum A times maximum A minus new minimum A divided by max A minus min A. After this plus new min A is the same thing. This divide by this is the
I know what I'm going
right?
to do. Yes, okay. I know what I'm going to do. I will carry that new minimum A and remove it from
this is
that place.
This is the division, no? This is the division. This is added.
Yes.
This sometime shortcut and trick is very important than learning the formula.
So please, can you repeat that one you said before, using destination range over source range multiplied by...
Okay, let me tell you. You see this, V dash, right?
Yes.
Destination. Are you getting my point?
Yes, sir.
Destination, you can say range, maximum minus minimum, right?
Yes, sir.
Divide by
source range.
Source range. It's the same thing. This division, right? This new minimum, new max, new minimum, divide by max A minus min A. After yes, this, we call this as a scaling factor. What we call it, class? Scaling factor. If this is less than 1, if this is greater than 1, object will be bigger. If this is less than 1, it will be smaller, right? Yeah. Scaling factor. After this scaling factor, once you have this, you are talking about source value V, right? So this V minus destination lower, right? Source lower, right? V minus source lower, right? Hello,
yes, sir.
class?
Yes,
source sir. Lower, this multiplied, plus after this multiplication, this is destination lower.
Okay.
This is easier to understand, right?
Yes, I think it's easier to understand. Yes, sir.
I don't know whether you can see it properly. Let me read it. This is destination range. Divide by source range. We call it scaling factor. Once you get this number, multiply this with V minus source, any number which you want to transfer, minus source lower. After this number, you are adding this with destination lower, right?
Yes, sir.
You can write this formula also, not necessary to learn in this way. It is just notational difference. But I used to remember by this method. I'm not remembering by this method. If I'm remembering by this method, I may forget. Are you done?
Is something here. But what I discovered is that if we follow the formula V prime the way it is written, it will not tally with this one that we used to do the calculation.
No, it will not tally. You have to learn it again and again. But this one, you are yes, done today. It is forever, right?
Yes.
This is forever.
Yes,
This
sir.
red one, this is forever. This is forever. Now, but this is not forever. You have to learn it again and again.
Okay.
Can I go ahead, class?
Yes, sir. Thank you, sir.
Okay. You know, this
Yes,
is
go ahead.
point. Yeah, this is
Maybe.
the point in one dimensional. This is point in one dimensional, right? Let's talk about two dimensional. Maybe I will erase it, then do it separately so that you should do it by face, right? Otherwise, you may be confused. Is it okay? Clear?
Yes, sir. Go on, sir.
Okay. Now, suppose class, try to understand this. I'm generalizing the transformation. Suppose you have multi-dimension. This is your x-axis, 2-dimension, and this is your y-axis. I hope you understand the concept of x and y axis. Yeah, right? This is your x coordinate, this is your y coordinate. And this is a like a rectangle in x and y coordinate, right? This is your rectangle. This is defined here. And same thing in your x and y coordinate. You know, you if I don't know if you have done the physics, and you might have done theory of relativity in physics. It's very interesting topic, but I'm not like going to discuss over there. And this is going to be transformed here. This is, yeah. Now this is your 0, right? This is 1 and this is 2, this is 3. And same thing, let's say this is 3 and 3. My point is that
Doc, please let me. I want to leave the meeting and come in again. My network is messing up.
Can I wait?
Go ahead. I want to leave now and enter again.
Yeah, it is permitted. You can leave anytime, you can come anytime. I opened the meeting. Three, 4, 5, 6, 7, 8, 9. You know here 9, 3. 9, 3. 3 is y-axis. X-axis is changing to this. Same thing here. Let's say this guy is 3, 4, 5, 6, and 7. This guy is 3 and 7. Right, and this guy is 9, 7. 9, 7. This is like very important for 2 dimensions. And here is a person. Here is a line, is a point like here. In this thing, there is a point. 1 minute. There is a point in this coordinate. This point need to be transformed here. And what is this? This is origin, right? And this is 1 and 0. And this is 1 and 1. And this is 0 and 1. And this point has x-axis as, let's say, 5 and y-axis as 4. Its coordinate is 5 and 4. This point coordinate is 5 and 4. This is the point which coordinate is 5, 4. Can you write down the figure? Make the figure, class. Noted, class? Please tell me once you are done.
So the P is 5,4, right?
Yes.
Okay.
You know this is two-dimensional. Earlier P was only one dimension, right? Now we are talking about two dimension. I'm asking your opinion, how to convert it. How many of you are understanding the problem?
The first one we did under the reversible transformation, that one you said is one dimensional, right?
Yes, this was one dimensional.
Okay, so that formula will not hold here, or will it?
Why? Are you changing the formula for every dimension separately?
That's what I'm asking, so that now which of the scales the point, because we have a 5.
What do you need? What do you need to transform this point to the destination? Just tell me. What do you need? Just tell me. What do you need?
The which one? The one that will be the max A and the minimum is a 0.
Okay, so what is destination range? Tell me the destination range.
0 and 1.
Okay, 0 and 1.
Okay, you know your point P is having X and Y dimension. Am I right?
Yes.
So if
Yes.
you are sending to the X dimension, check the destination range of X. What is this destination? Tell me. Is it not 1 minus 0?
Range
is.
1 minus 0.
And what is source? Tell me.
5.
Is 9.
You remember P is
9,
X
3.
axis. 9
9,
minus 3.
9 minus 3
How much is this, class? Is it not 1 by 6
is 1 by 6.
multiplied by, you are interested in this number 5, x-axis, you remember, 5. And what is its lower range? Tell me, what is its lower? X. Is it not this value lower?
3.
Yes.
This plus, what is lower of the destination?
0. So the 5 is from the point that we are working on, right?
This point, class, you know this point, right? You know it is having two dimension. You did for one dimension. So now this is two dimension, right? This is 5. 5 1 dimension. It is x-axis, x dimension. So you are interested in x dimension and x dimension only. So this is 2 by 6, right? Plus 0. So this is actually 0.333. Everybody will fall into this range here, right? Class, are you getting my point? 0.333 comma. Okay, let me know the answer in. Okay, let me give you 2 minute time to calculate the y coordinate. Calculate the y coordinate. You transform the 5, which was the x coordinate. Now you need to transform 4. Go ahead, class. Let me see how many of you are correct. It's an interesting problem.
Since 0.75.
0.05. Let other do the thing.
Is it 0.25?
0.25.
I got 0.6.
Keep trying. Okay, let me do it, class. Look at here. You are doing this for destination difference 1 minus 0. Look at here now, 1 minus 0. So scaling will be 1 minus 0. I hope you understand it. Source y axis, 9 9 remain the same. 7 minus 3 is 6. 7 minus 3 is 4. Okay. So destination by source, you are interested in 4 minus minimum is this 4 minus 3 plus destination lower of y-axis. You remember, point you need to be noting, this is the y-axis lower, this is y-axis lower, right? Yeah. So answer is 1 by 4 times 1 plus 0. So class, you should get 0.25. If you are getting 0.25, you are correct. Otherwise, you are not correct.
Yes, that's what I got. 0.25.
It's very simple, if you are you need to correlate from one dimension, you have to go to two dimension, from two dimension you have to go to three dimension, multi-dimension. So you see, here is like this is y-axis, and you need to calculate the difference of y-axis, not here. Some of you might have not calculated 7 minus 3, right? Class, this is 7 minus 3. You remember, this is 7 minus 3, 4. Because this we are interested in y-axis, y point. We are not interested in x point. And you remember, this is the lower this. This is the lower this. Hey, class, clear?
Yes, but this, I was looking at this, it looks like 3. This y on a major, this, I saw it now, it's 1.
7 minus 3 is 4, right?
Yes, sir.
So why you are looking at 3?
No, I'm talking about the destination. I've seen it is 1.
Destination is, this is y-axis 1 minus 0.
It's
This
correct,
is
sir.
also 0, 1. This
Yes.
is 1 minus 0.
Yes, so that is the one I was looking like 3, but it's okay, I've seen it. It's 1.
No. But you remember, I told you that this is unity square, right?
Yes, sir. Yes, sir. Yes,
But
sir.
explanation is clear. I told you on the day 1 that this I'm writing with the laptop. That's why my head, I used to like, my hand is always paining after the class. Because this I'm writing from the laptop. I don't have smart or something. So this is the keypad I'm writing.
Okay, it's clear, sir.
Yeah, that's why the writing is not very, very clear, but it is manageable, right?
Yes.
Yes, sir. Yes, sir.
Yeah, बेटा अभी मांगे No, if you have any doubt, I can explain it further.
Okay, you can explain further because this dimension, though now I understand from the arrow you put there, from the upper limit and the lower limit on the y-axis.
Yes, you know, if you are talking about this destination of this y point, right? This is the destination, 1 minus 0. It's the same thing. It is unit square, 1 minus 0. And divide by source. So source is 7. You know, 9 same. 7 minus 3 is this. And you know it already. 4 is the y point, 4, and its minimum is this. You remember, this is the minimum. You want me, I can give you another question so that you should be confirmed. Can I give another question?
Yes, sir.
Because it seems that in two-dimensional your concept is like shaking. So you know, on this we have to work on multi-dimension, not on even two-dimension. You have to work on multi-dimension, multi. Yes. This is 3, 5. And this is 6, 5, right? And this is 6, 10, and this is 3, 10. This is the window. 3, 10. Look at here, 3, 5, 6, 5, 6, 10, 3, 10. Here is a point, and its point is 5, 7. 5, 7 is the point. And this is going to be transformed to 2, 3, 7, 3. Yes, here. Go ahead, class. Your time is start now. Hello class, are you not done?
So, 5.3 and 6.6.
Can I do it so that you can verify it finally? Class.
Yes, sir.
Yes, sir.
You can verify that where you are doing the mistake. Okay, let's start with destination scaling. How much is the destination? 7 minus 2, is it 5? Correct? Class.
Yes, sir.
Yes, sir.
7 minus 2 is 5. Divide by 6 minus 3 is 3. Am I right?
Yes, sir.
Yes.
Very correct. And this is 5. You are interested in scaling 5 minus its lower is 3.
3
Yeah.
Minus 5 minus 3.
Yeah.
plus 2.
The lower of this destination is 2, right?
2. Yes, sir.
Yes.
Is it the same question, same answer?
Yes.
Yes, sir.
So that means you understand now. Yeah.
Multiply by 2
That's
2.
plus
What is
2.
this value? 10 by 3
plus 2.
Plus 2.
That's 5.3333.
Yeah, 5.33. You know this approximation, right?
Yes, sir.
Good. This is one of the answer. See, let's do it the y dimension. You remember this 7 is in the y dimension. So what is destination in y? 12 minus 3 is 9, right? A class, right?
Yes.
Plus minus 3, yes.
And what is source? Source is 10 minus 5 is 5, right?
Yes, sir.
Into 7
7
minus.
minus 5.
Very good, very good. This is the lower. 7 minus 5.
Plus
Right?
3.
Plus this is the
Plus
3.
3.
Remember, I changed it intentionally so that you should remember the thing, right? This is
Yes, sir.
3. Yeah. So this is 7 minus 5 is 2, 18 by 5.
8, yeah. Plus 3.
Where did you get the 7 here now?
Where you get 7 class? This is the number now. You are
Yes, the
interested
7.
this.
Okay.
is
And
is
5.
at the middle point.
5 is 10 minus 5. This is the y range. This 5, this 5. This
Yes,
is the,
that 5.
this is the number. This is the number. This is the 1 5, right? You see here, this 9 is 12 minus 3, right? And this 9 is 12 minus 3, and this
5
5,
is 10 minus 5.
this 5 is 10
10
minus
minus 5
5.
on the y, yes.
Yeah. So now I don't think that you are left with any confusion, right?
No, sir.
Yes, sir.
Yeah.
That's 6.6.
So this is clear that, you know, if you are given even in 3 dimension, you can do it. 3 dimension will also not be a problem, right? But you can limit up to only 2 dimension. 3 dimension is not needed.
Okay, sir.
So class, I hope this is not having any issue. You understand it well, right? Yeah.
Yes, sir.
Yes, sir.
Let's go to the next one. Data transformation, and the next is standard score or Z score, right? So as I told you that this is going to be the same. Purpose is the same, that you have different marks in different subjects. So we are interested in deviation, that how much deviation you are getting from the value. So you know what is the standard score of any number? Any number is number minus mean of the data set divided by standard deviation of the data set, right? So suppose you have a data set whose mean is given and the standard deviation is also given. So what is standard score of that value? Subtract mean by that number and then divide by standard deviation, right? Class,
Yes,
is
sir.
it clear? Yeah. So can you just let us understand? Suppose that the mean and standard deviation of the values of the attribute income is this and this. So this is mean and this is standard deviation. With what is Z score of 73,600? So what you should do, Z score of 73,600 will be like V minus 73,600, right, minus mean is this 54,000, yeah, right, divide by standard deviation is this. You see, this is standard deviation. This is standard deviation.
16,000.
Yeah, this. That is the Z score. And this will be 1.225. 1.225. Clear? Clear, class?
Yes, sir.
Yeah, note down. Note down this.
Sir, can we see the formula again? Okay. That the value V is called what? What does V
Yeah, the
represent?
value V, you know, just like you did, value V means if you have number 73,000, which word, just like you have been translating, right?
Yes,
Okay,
yes.
sir.
Just like V was here,
Because I
5.
can see clearly that. Okay.
Yeah.
Okay. This is very straightforward, sir.
There is sweet formula, right?
This one is okay.
Yes. It's a straight formula, sir.
Very sweet, right?
Yes, sir.
And you
Maybe-
like it.
Maybe I have to.
I like it very. I like it, bro.
I have to understudy that two-dimensional again. Probably when we get the video.
Yes, definitely. And you know, I can give you 3-dimensional homework. Right?
Okay.
Okay. Let's finish it. You see,
Let's
this is
see two-dimensional first.
this is math out of 100. This is mathematics score, right? 50, 60, 70, 40, 30. And a boy is getting 80 marks. This is ICT 100. 90, 95, 179, 85. What is Z score of a boy who is getting 80 here? And what is Z score of a boy who is getting 80 here? Note down the question first.
Okay. This one is maths.
Out of 100, then right hand side is ICT. Noted, class? Hello, class.
Yes, doctor, we are here.
Yes,
Okay,
sir.
so what do you need? You know, you don't have now is mean and
Yes.
deviation.
The
So
standard deviation, yes.
yeah, so your objective is to get mean of this number and mean of this and the standard deviation also, right? I hope you can calculate it.
Yes, the mean for the mathematics is 250,
Okay.
and the mean for
No,
the
mean cannot be 250. 250 by 5.
Divided by
okay,
5.
yes, by 5, and
So how much?
449 by 5. Yes, correct.
50, right?
Yes,
Okay, can we say that this is mean?
89.8, and 250 by 5 is 50.
Is
How much
50.
is mean of this ICT?
89.8.
Good. And what is standard deviation of this?
For which one?
Math.
Bro, we need to get the formula to find the standard deviation because we only have the mean here.
You don't know the formula of standard deviation. You are
That
not.
would be
You are not done mathematics.
Square
We
root
did
of that of 50.
Is the square root of
Deviation from 50. Look at here. This is mean. So deviation from 50 is 0. Deviation from this is 10. Deviation from this is 20. Right? And deviation from this mean is 40 minus 10, 10. Am I right? And this is 20. Right? Clear, class? Hello?
yes.
I'm even going
Yes, yes,
I'm just
yes.
I'm ignoring the sign. You know, 50 minus 50 is 0. 60 minus 50 is 10. 70 minus 50 is 20. 40 minus 50 is minus 10. And 30 minus 50 is minus 20.
20.
Square them. 0, 100, right? Right? And
40.
yeah, square them, no?
Yes, it's
400.
200. 400, yes, sorry.
And this is 100.
400, then
And
400
this
again.
100, yes.
divide them by 5. How much is the answer?
We add and divide by 5 now.
1000, right?
1000 divided by 5, yes.
200.
And what is square root of 200? Calculate square root of 200.
It's not in this. Not in this.
14.14, right? 14.14. Am I right?
Yes.
Okay. I gave you this is square. This is standard deviation. Go ahead and calculate it here also. You can do it the same way and do the calculation. Right? Can you do it by calculator? Or I can leave homework?
Yes, we can. We can, sir.
We can do it.
You want to do now? Or you can take homework?
Yes, let's try.
Huh?
Okay, that is 80 minus,
It's 89.8. Oh.
is it?
Yeah,
No, the given V
89.8.
is 80.
No. The mean is 89.8, not 80.
Yeah.
For ICT.
Okay. No, I'm talking of mass, but we can, no problem.
Okay, are you doing the Z-score already?
Okay. Let's finish
the standard deviation for ICT.
Yes.
Okay, let me just do it for you. 50.
So we can do it. 14.14 is the left one, is correct, right?
Yeah, 14.14.
Right one, calculate the right one.
Well, 95 minus 89.8, 5.2. We have 100 minus 89.8. We have 10.2. 79 minus 89.8. Wow.
It should be 7.35.
10.8. 85 minus 89.8. Wow, 4.8. Okay. So, okay. 4.8 plus 10.8 plus 10.2 plus 5.2 plus 0.2 is 31.2 divided by 5. Divided by 5. Sorry. 31.2 divided by 5. 6.24. So the square root of 6.24.
It should be 7.35.
6.2. Square root of 6.24.
You should be getting the square root of 54.16, right?
54.16 from where? No, what I'm getting as after I use the 89.8 to subtract the figures, I added.
You are getting 270.8, right?
No, I didn't get 270.8. Because the numbers are small, they are not big.
You know what you are getting. You see, look at here, 90 minus, you are getting 90 minus 89.8, right?
No, 90 minus 89.8 is 0.2.
And it need to be squared, right?
Yes, you need to be squared.
Yes.
Then 95 minus 89.8. Same thing need to be squared. Is it clear?
Yes, sir.
So
Okay,
if
I did not square it.
Oh my God.
Okay.
That is squaring. I squared here. You remember?
Yes,
we squared.
Here.
So we can do. I
take
think
it
we
from
can
there.
do that because it involves points. It involves small
That's
numbers.
I told you that take it as a take home, and you are saying no. I want to do it over here.
No, that we can do it later, sir. We can.
Yeah, that's its standard deviation should be 7.35.
Okay, sir.
Right?
Okay, sir.
Yeah, and its standard deviation was 14 point.
Okay.
So what is its Z score? Tell me. Z score of 80. 80 minus, right?
Yes, 80 minus 50.
mean, right?
Yes, divided by 14.14.
Calculate it fast. Let me know the answer.
Okay.
80 minus here.
2.12.
How much?
2.12.
2.12.
Good. Calculate here. 80 minus here. 80 minus mean of this. Mean of this is 89.8,
89.8.
right?
Yes.
Yes.
Divide by 7.35. What is value of this?
Negative 1.33
Okay, which one is higher?
is 2.12.
2.12.
Remember, you need to take the sign also.
Okay.
Right? Yeah, you need to take the sign. So 2.12 is greater than this. So that means the boy has done better in mathematics than, you see, this is same score 80 in mathematics is high, better than other, you see. And look at the proportion. 80 was not good because you are getting 195, 90 also, 85. So this boy has not done well. That's why, you know, if you compare that boy performance from both the perspective, mathematics is getting highest. So that means he is number one in mathematics, but not in good in ICT. That's what that I was trying to explain you, but you people were saying no, ICT is better, ICT is better, right?
Yes, we are saying it's based on performance, not by scaling.
Yes.
Or
Now,
it-
but you have seen the performance of the class, right? So based on this kind of performance, you cannot say that a student has done bad in mathematics, because maybe it is a class who has done worst in the mathematics and boy has done better than them. I think it is clear to everybody, class.
Yes.
Yes, sir.
Okay, so I'm stopping now, and one more is a transformation remain, that is decimal decoding, but we'll cover by next week, right?
Okay.